All right, we're going to discuss our Chapter 7 topics tonight, and you can see the topics are telecommunication, internet, and wireless technologies. I'm going to be jumping directly to slide number 6 here. And as that loads up here, the reason I jump right to this, and really, the first topic or content slide is the next one, but this one really talks about how the case studies that open the chapter, what is it really kind of all about? And a lot of what's happening right now is an era that was predicted a while ago. Like when I was finishing up my college degrees, they envisioned a future in the near term where we had what we called converged multimedia technology. That's how they were pitching it to us back then. And so they were seeing this age where the internet would start to replace our traditional communications channels, replace our traditional channels of how we receive our media. So in other words, television, radio, music, movies, all those things that we now kind of take for granted. But how that really relied on infrastructure. And at the time, they just didn't have the infrastructure. They were just building it back then. In fact, here in the Midwest, we kind of benefit from that quite a bit because we had these multiple buyouts of the phone company. So they decentralized AT&T to start with. And then we started, first they went to Wisconsin Bell. I don't know if you guys remember that, right? That was the phone company. And then SBC bought them out, and then Ameritech bought them out, or was it the other way around? But when Ameritech came into the area, they had this vision of getting fiber optic in the ground and on our phone poles much faster than a lot of other parts of the country, and they did quite a bit of that. But now we are definitely in this era where this corridor where we live between Milwaukee and Chicago and kind of Madison is one of the best wired parts of the country. We really have very excellent bandwidth if you study the internet charts on it. There's some areas that are a little bit better. For example, like if you're in like the New York City area, Boston, Silicon Valley, the LA area, those areas tend to have really strong networks too. But we're right in league with all those areas, partially due to population, and thank you to Chicago. Pretty much everybody's got broadband internet now. I don't think that you can even get dial-up anymore. I don't know if there's anybody that even provides it. That's kind of interesting to think about. The chapter kind of starts out with talking about what is a computer network, and the bottom line is it's a connection between computers. We've talked about this in the other class too, so we're not going to go into like my whole little dog and pony show about like copper wiring and fiber optic and Wi-Fi and all those things in that kind of detail. So I assume that you've had that information there, but we look really at kind of a combination of technologies, the connectivity devices, and then what is used to connect them. So like, if you have a laptop or a desktop or a game system or whatever, are you connecting wirelessly or with wires? And then what are all the infrastructure pieces that put that in place? The other thing that we kind of look at a little bit is this concept of what we call software-defined networking. And that's something that's growing quite a bit because we operate over the public internet. And so we create software structures that simulate private networks so that we can do our work on the public internet. This Zoom session is actually kind of an example of that in a way, right? Because not anybody can just jump into this. You have to know that magic address to get to it. I think for the most part, we don't allow guests in. I think I have my guest switch turned on, but it usually has to be somebody from the mail.gtc.edu domain or the gtc.edu domain in order to be able to join in on the session typically. All right. If you look at kind of like the basic components, this is kind of what we were talking about. It's the computers that we're connecting to the endpoints, but all the other devices that sit in between, the switches, the routers, the Wi-Fi receivers, the 5G, then the entire internet, which is really just a mass of connected devices. Talk about the concept of, what do we do with networks in large companies? And, a local area network, we've talked about that in the other class. Usually we think of that typically in terms of one building or a few buildings really, really close together. There's kind of a physical limitation for Ethernet traffic. Does anybody know how long a wire run can be for Ethernet before you have to repeat it? It's kind of a weird thing. It's about 300 feet, so roughly the length of a football field. And then you have to have a device in line in order to repeat the signal. So, most, people that run LANs within a building, therefore usually put the connectivity devices in very strategic spots in the middle, where they can get to most of the computers in the building, or they have repeating points throughout the building. If you guys ever get a chance to visit campus, like in person, like our classroom, for example, we have some networking equipment right next door to where our classroom is. But if you see the Racine campus, and I don't know how many of you have ever been there and see our server closet there, and then you look at how many pieces of equipment we have just running one floor in the building. It's pretty impressive. And when you start to extrapolate that out and you think of these huge skyscrapers that have these systems that it gets pretty mind-boggling pretty quick. This is kind of a typical breakdown for a corporate network. Not too dissimilar from a home network, except at home you typically don't have servers unless you're an IT geek, right? And mostly at home we don't run our phones over IP networks, but most corporations do and have for a really long time. The whole concept of voice over IP, for example, because it really is traveling over that same packet switched network. And we'll talk about that concept in a little bit. Some, key technologies, there's a series of slides here about it. This whole concept of client and server, the fact that we have one machine that either holds all our files or runs our applications. And then we have less powerful machines that connect to those devices to do their work. Centralized computing like that is often very easy to administer, which is why it's preferred in corporate environments. It allows for a lot more control over upgrades, the ability to solve problems remotely, et cetera, et cetera, et cetera. This concept of packet switching, this is one that I find really interesting too. And if I had the time, I would play a video for you, but we prioritized our group work, which I think was the right thing to do. But there's some really cool videos out on the internet that talk about the history of the internet and this particular technology. And I'm going to kind of try to make it as brief as I can. But I think it's very important to understand this concept. In the old days, when we first put telephone networks together and we would establish a connection from one person to another with a phone call, the person picks up their phone, they dial the number, and your device is then connecting to your local central office. It's a switching house, somewhere in your area. It's a building that basically has all that networking gear, right? The routers, the switches, and the connections to all the other central offices so the phone calls can be routed. When you make that phone call, you use a technology called circuit switching. So if you think of like the Andy Griffith TV show, right, where they would like make a phone call and they would like turn the handle on the phone and it would ring Mabel and Mabel would take the cord, and it kind of looks, kind of like a guitar cable, kind of like this, right? And she would plug in from one person's connection to the other. She was establishing a circuit. And while those two people are talking, those two communication, wires, which is all they are, copper wires with electromagnetic signal going over them, that whole connection is dedicated to just those two people. When they started to realize that we wanted to connect computers together, they also realized computers worked in a lot different way. Computers worked in a fashion where they're not always sending and receiving information. And in fact, a lot of times what we do on a computer is predominantly passive. So for example, I might go out to the internet, do a search, hit the button, follow a link, and bring up a page. And then I'm scrolling and reading and looking at it for a bit and thinking, and then maybe typing a message and pressing enter, right? But most of the time, I'm not really sending information back and forth. It's just like in little bursts. And so what somebody thought, and I didn't mean to jump that far ahead, is that that's really inefficient use of a communication line. So if you're barely sending any data over the line, wouldn't it be more efficient if we could allow other people to use the same line? So that's why they developed packet switching. So what packet switching does is it shares the communication pathways between many devices. And in order for that to happen, we have to take the information that's being sent and snip it up into little pieces and put an address on each piece. Where did you come from? Where are you going to? And what's your information? And so an image or a document might be split into thousands of pieces, each piece taking its own pathway over the network and the internet. And I want you to think about that. It's pretty crazy, right? It's like writing a letter, ripping it into pieces and putting it in 1,000 envelopes and then sending it off and hope it gets to the other end and put back together again. But that's exactly how packet switching works. And it uses that capability of the internet once it leaves your local network to travel many pathways to get to the same destination and then magically be reassembled at the other end in the right order and the message is received. All the while taking all those lines of communication and using them as efficiently as possible, allowing in many cases hundreds, thousands, tens of thousands of connections to be made simultaneously over the same lines. And that's really a powerful concept. And it's really what's kind of enabled a lot of the internet stuff to work. And this key technology, TCP/IP, which is our addressing and error control and software platforms through the networks. What's interesting about this protocol is it's getting really old, right? This was developed right when the internet was developed, so the conceptions go pretty far back. Even as it developed, it was not seen as the best network protocol. It won out just simply because the internet won out. And some people are saying that we need to rewrite this. This is one way we could make the internet better and more efficient, actually, is by rewriting this protocol. Talks here about how traffic moves through this model, right? And you guys learned about this in the other class as well, where you have an application, it transports through the internet, through the devices, and back through to the other side where it's received by another application. That's one of the reasons why you learn about the OSI models, is certain pieces of software and addressing happen at different levels. All different types of networks. Typically you learn about LANs to start with, local to a building, but wide area networks are very huge. And then we have these other constructs like campus area networks. This is actually a fairly new term in the field. We used to kind of think of, localized WANs, and in some cases we would call them MANs, like that, because you're operating in a metropolitan area. And so I think of, like Harley Davidson, for example, here in Milwaukee, they have many different facilities. And I know that they have them all running over private dedicated lines. They don't go out on the public internet. They have lines that they pay for that run between each one of their facilities before they go out to the public internet. And why would a company do something like that? Because nobody could steal their communications. That's one thing, right? The only one that would be capable of doing it is whoever their network provider is, like AT&T or Verizon, typically one of those two. Campus area networks, Gateway totally has one. All our campuses are wired together. In fact, we used to have a way, if we were on campus, I could demonstrate it. They have a campus map you can actually tap into through a browser. That's attached to every one of our routers. You can tap into it. You can see the whole network infrastructure of Gateway. All our campuses do have direct lines to each other and redundant backup lines as well, with huge upload speeds, by the way. Whenever we move information across a network, my voice is a perfect example of this. It has to travel over the network in a digital fashion. It has to be those electronic pulses of ones and zeros. And that packetization of the information is also what makes packet switching possible. If we didn't use digital, there's no way that you could packet switch. So in a way, packet switching is really what developed digital communications, interestingly. But whenever my voice speaks, I'm generating sound forms, waveforms through the air. They're smooth and analogous shapes. And then when we take a wave like this in analog and convert it to digital, we turn it into these ugly square shapes that, unless there's a significant amount of sampling or snapshots of the moment in time of the analog signal, you are losing information, right? So even if you listen to, let's say, a CD, which is higher quality than an MP3 file, you are still losing information in the recorded original analog sound. And I think that's always very fascinating. The technology is getting better and better. So as the sample rates increase, the digital to analog conversions improve, and our bandwidth improves. It's all those things together that even enable us to be on Zoom here. This was unheard of, you guys, like 10 years ago. There's no way you could like group video chat with people. Nobody had the bandwidth. Very, very few people. It was only on internal LANs where you could get the speeds that you needed to make it happen. So, a really good example of how things will change. Talked about all the transmission media in the other class too. We have, the copper formats, the twisted wires, the coax, those are both copper. Fiber optic, where we use light to send the information, then all the wireless technologies, Wi-Fi, Bluetooth, WiMAX, the new satellite systems, cellular systems. I forgot those. I'm looking at the slide. And the speeds are increasing dramatically. 5G is here, and I keep noticing, and I'm in this habit now, like wherever I drive around, I'm looking for them, because they, in some cases, they try to be pretty clever in hiding them. But they're very short. They're as tall as like a street light, and they usually have a round, I guess, router at the top. I don't know if that's the correct term for it on that level. And in some cases, they also operate 4G and 3G off the same little micro tower. Very interesting, though. But when we start to look at like the whole concept of the internet, which is a network of networks, and how we kind of moved our way up through all these different speeds of providers, and these days, we have so much bandwidth available to us for really a very reasonable cost. It impresses me, and I'm thinking even to myself right now, boy, I should probably bump up my speed here at home. We spend so much time online, we work that way, and I always suggest to people, get as much internet as you can afford, because if you're doing all your stuff that way, technology people, it pays to have a good connection. Plus, you can stream, multiple people at the same time, and it improves your up speed at the same time. The internet addressing scheme, another thing we learned in the other class too. The IP version 4 scheme, which is that works in this fashion that you see here, is one that, at least on a planet-wide basis, has been exhausted for a long time. But the way that we've worked around that is all of our internal private networks will give us our own separate IP structure. And so that's how they've kind of circumvented it. The internet always operates on numbers, folks. We use names in our web browser in the address bar because that's what makes sense to us. But we do have special systems called domain name systems, which translate those words into the right numeric IP address in order so you can get to the right system. In the old days, believe it or not, when the internet was kind of fresh, there would be times where some of the main DNS servers would go down on the internet. And so all the name to address translation would be offline. And so sometimes if you didn't know the IP address of the machine you wanted to connect to, you wouldn't connect. And that's kind of interesting. If you guys want to try something really fun someday, and I don't know if you guys do geeky stuff like this, but you could bring up a command prompt. And you guys know what a ping command is in networking, where you're sending out a network signal. And in the old days, you could ping just about anything, and now a lot of people have it locked down. I think Yahoo is one of those places that always left it open. And so, here is Yahoo's address, right? And so I could take this address, 74.6.143.26, if you remember that. I'll just move it over to my other screen, and I put that in the browser. It should take me to Yahoo. So let's see, 74.6.143.26. All right. Well, it is Yahoo, but not the homepage, right? But proof, that it is a Yahoo machine. But they have that one up there. They have always put it up there. Just about anybody else major that you would ping would come back probably not responsive, by the way, because once you know a place's IP address, now you have a way to attack them, because you know their address, you know where they live. All right. We do have some organizations that actually govern the internet and establish standards. The one that's probably most important here is ICANN on this list, which is the one that takes care of all the domain name addressing and IP addressing in it. It is an organization that's based here in the United States in the state of North Carolina, and up until about 2 or 3 years ago, it was solely controlled by the United States. So that's kind of interesting. The United States, because we kind of originated a lot of this stuff here, we ran all the databases that ran the internet. And I think that I want you to just kind of think about that for a second. It's pretty profound. So if we wanted, we kind of have an off switch for the whole planet. It's basically, and what happened on the international level is they're like, that's not really right, right? And and really think about it, it's not. And so they internationalized it, even though most of the control and servers and stuff are still here. It is run by an international body now, and I think that's a good thing. These other two organizations either set the standards for the transmission lines, that's the IAB, or the W3C, which sets all the protocols for the internet. So when we learn HTML or any communication that flies over the internet, this organization determines how it goes over the internet, the actual protocols. Pretty interesting. They talk a little bit here about the infrastructure of the network and the fact that the internet really kind of operates on a backbone. And I hear a lot of people describe the internet kind of like as a cloud or like this mishmash of connections. And the truth is, it's not really like that. There are, in some cases, very central backbone lines that connect the country together, and they run through certain parts of the country. Some of the biggest networks in the country do run through Chicago, right? So that's why we have such good bandwidth here. As you can imagine, there has to be a big connection between New York and Chicago. I mean, those are the two of the biggest metro areas. And so we're just a little branch line off of that. And where do you suppose most of those lines run in our area? Right along the I-94 corridor. Usually where the train lines are, usually where the high power lines are, the freeways, a lot of those types of structures. So I think that's kind of interesting. They've been upgrading the backbones everywhere. I don't know if you guys like see the fiber trucks out there doing their installs, but there's a lot of network upgrades going on right now. They're going on in my neighborhood. I see them all over the place when I'm driving. This work from home era is kind of pushing us very quickly forward on a lot of our infrastructure projects. Here's a couple of interesting technologies. One, let's talk about IP version 6. So this has been around for quite a while, and they came out with a while back this new addressing scheme to allow, I forget what it is, I think it's 1,000 IP addresses per square foot of planet Earth surface area, right? Which should be more than enough, right? Ideally, we would never have that many devices, but that would allow all the devices to have their own unique addressing structures. So any individual device could be directly addressable through the internet. That's one of the practicalities of this. A lot of our networks do serve up both IP version 6 and IP version 4 addresses. How they're used is usually controlled by your local area network. So maybe on your local network, IP version 6 is running, but on your internet service provider, it might not be. So that's something to think about. Routing is supposedly faster too. Did you guys ever hear that there's an Internet 2? And it's actually been around for decades. And in fact, in the late 90s, they started this. They started building super, super high bandwidth networks. And they do actually list that 100 gigabytes is the backbone, minimum connection, by the way, to the outside world. That's pretty huge. I mean, when they first started this, they were working with rates like this when most people were working with 56K lines. I just want to kind of put that in perspective. Now what's happened with Internet 2, it's a separate physical network, but now our normal network speeds are approaching those speeds. And so they're thinking about upping that to another level. And who's on it? Well, just as how the internet started, just these really very select organizations, usually high-end research universities, big corporations, usually with government or military ties, government agencies, and other related institutions. And if you want to think about that they have their own private network that works at higher speeds than our standard networks, they can't be intercepted then, you see, and that's one of the strategies of it. When it first came out, what it was most used for was university students moving music files around, by the way, really fast. When they first, wow, I can transfer a whole movie in 5 seconds, you know, back when it would take you hours to do the same thing. Moving on here, some of the key protocols for the internet are listed here: email, news groups, telnet, FTP. Some of these things you guys will touch in your studies, and some might not. The whole client server architecture is pretty huge. We as users sit here on this end, our traffic tunnels through the internet. We hit a web server, and then the web server will kind of route us to all these other different systems. Usually kind of tying them all together and feeding it back to your screen. And the fact that we can even do that and just be anywhere on the internet is pretty profound when you start to think about some of the history of computing and where we've come in mere decades. Most places did not operate this way even 2 decades ago. Now at this point, any organization that has probably 50 users or more will have infrastructures like this in place. Very similar to this. Interesting to think about. Right. One thing, technology-wise, that is a important one. We talked about creating kind of like virtual networks through the public internet. One of those really key technologies is VPN. We use that technology here. We're using it in our data analytics class to do our database connections, if you guys remember, for those that are in that class. And that allows us to create basically a secure tunnel to campus. And then we get an IP address from the campus network as opposed to our local network. And we are basically, via encryption, securely connected to campus and able to access resources that otherwise we'd only be able to access if on site. I heard a really cool analogy once from a speaker who told me that think of a VPN as a limousine with dark windows. Something important is inside of it, but you can't really see what it is because the windows are all blacked out. But it still moves along that same highway just like you do. And that's really a good way to think of VPN, because you could think of that one limousine as a packet of information traveling over a packet switched network, trying to arrive at a destination. They talk about voice over IP here a little bit. It kind of works very much the same way. And voice over IP really kind of requires that we stream our audio, right? And a lot of our streaming technology is based, upon inventions that came from voice over IP, using that packet switch network to take the voice that I'm speaking, convert it from analog to digital, break it into packets, send it over the internet through all the various little pathways it might take, assemble it at the other end in the right order so the person can hear you, and hopefully next to real time with like the minimal amount of delay. And that's profound, right? I mean, to what the technology does, and now we're doing it with video as well. And so really even my voice right now is really using voice over an IP network, but we're also doing video over an IP network. And in some cases, full HD video. We have 4 video feeds working simultaneously here. Very impressive. All right, moving on. Now let's skip that one. Let's go here. Some of this stuff we started learning about too in some of our other classes. Once again, the language of the web, which is HTML, and the protocols that we use to move the information. That HTTP stands for Hypertext Transfer Protocol. It's a very interesting concept, actually developed in concept significantly before the internet was developed. In fact, I always forget the guy's name, but in the 40s, he had this concept that wouldn't it be cool if you could create a book electronically somehow, and then whatever you're reading, if you wanted to like look up a concept or a topic, you could like touch the word, and then it would take you to, kind of like automatically indexing it and finding the glossary and the definition. And isn't it interesting that all these years later, after we do finally get the internet, and then 20 years into that process, Tim Berners-Lee figures out the principle of like unifying resources on a network through an addressing structure, and HTTP is that thing. So when you hear about people inventing the internet, no, it wasn't Al Gore, it was Tim Berners-Lee, who actually didn't invent the internet or the web. What he invented was a way to so-called surf the web, by creating links between resources on the web that we can then join together through URLs. So the uniform resource locator is just basically a way to find a machine on the internet. In some cases, we think folders and files. In other cases, they are application structures, but really an addressing structure that can take you to very specific things that sometimes are not just one thing, like one file on one machine, but maybe even a conglomeration of files coming from various sources. Think about those network schemes we were looking at, where there might be a database and an application and a web server and an application server all working together to deliver the content you see on the screen in tandem. And that's kind of the invention that he brought forth, was the way to look at that stuff. He developed the first browser, which was a non-graphical browser, a text-based browser. And then the graphical browser, of course, was actually invented by a couple of Wisconsinites, and a lot of people don't know this, when they were studying down at University of Illinois at Urbana-Champaign, where they created the Mosaic web browser as a school project, basically. So they took Tim Berners-Lee, command line browser and moved it into a graphical windowed environment, and then allowed people to use the mouse with it and put graphics into it. Revolutionary, right? And then that, of course, grew into a company called Netscape, by the way. Search engines are probably one of the things we use the most on the web, and they talk about that and Google's PageRank system. You guys can read about that in the book. But there's all sorts of different types of searches that go on and stuff that happens in the background. But search is a really big business. Google's clearly at the top of the hill on it. But it's one of the things that we kind of just do all the time on the web. Think about like what you do mostly on a computer. Usually you sit down, you open up your browser, you go to the address bar, and you're typing something in, a search, a word, a website, or whatever. But you're doing it all the time. Who'd have thought we'd even operate our computers that way, even to the point now where our search engines on our desktops, like what do you do if you want to run an application? You go to start, you start typing, program name, for example. And you know what? I can search the web right from here too, right? I can just type something, and if it's not on my machine, it's going to go out to the web and find it. It's just kind of a way that we've been kind of trained to use computers now. One of the things that people then need to kind of vie for is, how do you get to the top of search engine listings? So that's what SEO is all about. So it's search engine optimization. It's big business, by the way. People make entire careers of it. And sometimes it's something as simple as, structuring a web page with the right wording or HTML structure in order to draw the right search results. And big business, by the way. Let's take a look at this interesting little chart, which shows all the different search engine popularity. Now, I'm not sure exactly when they compiled this information, but this has changed significantly. I know that Google has about 90% of the search market now, with everybody else being squeezed down more. And they have Microsoft in here. What is Microsoft's search engine?
That's still Edge, right?
That's the browser.
Oh, okay.
Yeah, it's Bing technically, and I don't know if they're going to be rebranding that. Then Yahoo. I mean, traditionally those are the three big search engines. What most people don't know is that Microsoft, Yahoo, Bing, and almost all of the others use the same core search engine. It's really the original Yahoo search engine, now owned by others. And so really what it's kind of boiled down to is it's either Google or the tiny little bit of people that use the Yahoo search engines. I don't think those search engines are bad. And in fact, in some ways, sometimes they're better. And then you have some of the other weird ones like DuckDuckGo, the privacy one. You guys are aware of that one? Yep. All right. You have a nice little graphic here of how, the search actually works. And I don't expect you to read it off of this slide, obviously. But the way that they figure out, where websites even are is by crawling the web. So they have like software that goes out there and searches the web and adds your information to a database. But then it's also ranked by, PageRank, and that's kind of what this is about a little bit. Sometimes they look at the protocols that are used, the verbiage that's used, the validity of the website, and then they kind of page rank it. And it's really that algorithm that really separated Google from all the other search engines and got them to the point where they're so dominant. They came up with that algorithm, and it was those two young, Google kids literally working in their mom's garage that came up with the algorithm of doing the page ranking that brought them to where they are today. And I always think that's astounding. Web 2.0. Web 2.0 is an era that's kind of been active now, in my mind, since kind of like the beginning of the 2000s, maybe the mid 2000s. Web 2.0 is best explained by understanding what Web 1.0 is or was. And Web 1.0 was what I would call the static web or the passive web, where you would go to a website and typically you're looking at stuff on the screen, you're following links, you're maybe listening to audio or watching a video, but there's no interactivity. You're just absorbing the information. You are a consumer of the content. Web 2.0 is the era that we entered into real strongly, first with blogging, and then more notably with social media platforms. I think of MySpace and some of those services that started us out in Facebook in the early days. And Web 2.0 really is this. You are able not only to consume the content, but also to generate the content or react to the content, to comment on it. And that's pretty interesting, right? Because it's true, right? If you're on Facebook or one of those other platforms, you can share content, or you can just view other people's content, and you can do it in so many different ways now. It's very, very powerful. But that's called the Web 2.0 era, and the reality is we've been in this era for quite a while. They talk about all the different technologies, all the ones you see listed here, right? Interactivity, real-time user control, social participation, user-generated content, all those things. It really did start with blogs and syndication feeds, frankly. But then you also have things like wikis, right, where you can have multiple authors on a live web page, things like that. That's pretty cool. And of course, all the social media. Is there kind of a vision of the future? Some people are going to tell you that it's already here and we're already using it, and we just are not aware. And I'm kind of that mindset myself now. And look at some of the things they have listed here, right? So they're talking about the pervasive web, meaning everything we do is starting to get wrapped around it now. If you think about it, the pandemic really pushed us forward, I'd say 5-10 years easy into the future in some ways. But we deal with the Internet of Things. You guys hear that term, right? IoT. Have you guys had your IoT class yet?
Yes.
Yes. Excellent. What did you think of that class? Did you guys like that class?
Yeah, it was good.
Yeah.
I especially liked Wendy as a teacher. She's fun to have.
Yeah. You want to hear a really funny thing about her? She was once my student. So, yeah, isn't that weird?
That is a little weird, yeah.
Yeah. And I think she does a really good job of teaching those classes, Internet of Things, and a lot of those types of technologies. But if you look at this list here, we're already there. In my mind, this stuff is all happening. I think the real question is, what does Web 4.0 look like? But I think Web 3.0 is just kind of in its beginning phases in some ways. They talk here about the cellular systems and how they kind of went through all these different technologies, all the different wireless standards that we work with, Bluetooth and Wi-Fi, and a subset of Wi-Fi that a lot of people aren't aware of, which is called WiMAX. And we don't see that a lot in the Midwest, but there are a lot of areas that are, semi-rural, like a lot of Great Plains states in particular. I think of like Oklahoma and like Kansas have a lot of these where people buy into this type of a service. In some cases, they've experimented. Companies like Google have set up like Google Towns, where they just basically put up like one big Wi-Fi thing in the middle of town that goes out a huge range and run the whole city off of it. We've been probably doing more of this kind of stuff. You guys use Bluetooth a lot? Headphones, phones, car stereos, etc.,
Absolutely.
speakers.
Yep.
Yeah, but they actually have a name for that now. The PAN, right, where you're connecting up all your little devices like that wirelessly. It's not going through your IP network. It's a separate little network. What's the other technology that we use in our phones? It's called NFC, near field communications. Those are the same ones we use to, like, when you're at a store or a kiosk or whatever, use your phone to pay. You don't have to touch anything. Big fan of that. I like that too. Talk about the wireless LAN infrastructure. Um, yeah, and I think almost, most people tend not to wire any of their computers at home. Do you guys wire your home machines? Yeah, I do. I do too. Even my laptops, if I can. Um, why do you use a wire, Nick?
Long story short, video games.
Yeah, and the why, because you want the max bandwidth, you want the most stability, least chance of the signal dropping. A wire is always better. It always. Well, I mean, I'd say it's always will be, but they are coming out, now with Wi-Fi version 6, which helps some of those things. We talked about RFID chips. Those are little chips that are passive, of course, that operate on networks. And then I want to kind of get to this, because this is kind of like the IoT thing. This is almost kind of science fiction like, that we now take all those little IoT devices everywhere, and we have sensors everywhere. There's cameras everywhere, and all of it runs over our networks. And whether you like it or not, people are capturing data all the time. And one of the whole reasons we are valuable is because we are going to be able to take that data and manipulate it for people, and the knowledge gained from it is important. All right, I'm not going to keep you any longer. I realize it's late. Thank you guys for sticking around. This recording ends here.